It's another video tutorial series on which we'll be exploring as well as apply the Wilcoxon rank test. So, Wilcoxon rank test is an unparametric statistical test used to compare two dependent samples. In other words, it compares two groups consisting of data points that are matched or paired. It serves as a counterpart to the dependent sample t-test and designed for situations where the assumptions of the latter, particularly regarding the metric which is interval or ratio, and normally distributed data are not met. In other words, Wilcoxon signed rank test is a robust option when you are unsure about the data distribution or when the measurement scale isn't perfectly interval or ratio. So, with this test, it helps you to calculate the difference between sets of pairs and analyze these differences to establish if they are statistically significantly different from one another. So to fully understand the Wilcoxon signed rank test, let's run an example using our Excel. So here, the researcher wants to find the normality distribution and general knowledge of ABM and STEM students in general mathematics. So the research questions is there a significant difference between the general knowledge of STEM student and the ABM students in general mathematics subject? Again, here we have here the average grade of STEM and ABM students. All we have to do is to get the difference of our data. So, upon getting the difference of our data in this column, input equal, then the first data minus the second data, then press enter. So, after that, highlight to get the others difference. Now, let's proceed to the absolute differences of the data. So here, put it equal sign, then capital if the first difference is equal to 0, comma, quotation mark, comma again, ABS, and open parentheses, then the first difference again, and double close parentheses, and press enter. Again, highlight to get the other values. As take note, if you see an empty cell, it means it's 0. Let's continue on getting the rank of absolute differences of data. So let's put equal here. Then if, so our logical test is the first difference that is equal to 0, comma. In the value, if true or false, let's put quotation mark, comma again. Then input rank average. The number is the first absolute difference, comma. Then in reference, highlight all the absolute difference, comma. Then the order is 1. After that, highlight it all again. Next, we'll be calculating the positive rank. Input equals. Then if, again, our logical test is the first difference, but it is greater than 0, comma. The first rank of absolute difference, and the value if true or false. Again, let's put quotation mark, then enter and highlight. Same process on calculating negative rank, but remember that this time it is less than to 0. Then next, we'll be calculating the test statistic, which is the simply smaller of the sum of positive ranks or the sum of the negative rank. So in this cell, input equals again, MIN, then input sum, then the number is all the positive ranks, after that, comma, then another sum function, then all the negative ranks, and after that, press enter. Also, we'll be calculating the sample size, which is the total number of ranks that aren't equal to 0. So, let's put an equal in this cell and input count, then all positive and negative rank, after that, enter. Next is we'll be getting the mean of our sample size. In order to do that, type equal our sample size, or the n, multiplied by n plus 1 divided by 4. Now proceed by calculating the variance in order to get the value of our standard deviation. In this cell, type equal our mean multiplied by 2 times mean plus 1, divided it by 6, and then press enter. Now that we already have the variance, let's get the standard deviation, which is the square root of the variance. So, input again equal, then type the square root function, then our variance, and press enter. So, in calculating the critical value, we have two options. The first one is to use the critical table for Wilcoxon. What you're gonna do is to find where is the midpoint of the significance level, which is the 0.05, and the sample size. So, our sample size is 14. So, the critical value here is 21. So, the other option on getting the critical value is to calculate it. What we're going to do is to type equal the mean plus the standard deviation multiplied by the inverse normal cumulative distribution function, then our significant level divided by 2, then close bracket, minus the significance again, and then press enter. So, the result we got is the same, which is 21. Next, proceed to calculating C-score. So, here input equal absolute function, our t-statistic minus the mean, divided by the standard deviation, and then press enter. So, we're almost done. Only the p-value is left. Now, to calculate our p-value, just enter equal. Then, 2 times 1 minus the standard normal distribution function. Then, our z-score, comma. Then, the cumulative distribution, which is true. And then, press enter. To know if it's significant or not, just type equal. Then, if function our p-value is less than 0.05, then the value if true or false, just input yes or no, then press enter. So now to interpret our result or the data, the result shows that there is a significant difference between the general knowledge of STEM students and the ABM student and general mathematics subject. So based on our p-value, 0.003 is less than our significant level, and our critical value, which is 21, is greater than the t-statistic, which is 5.5, which means that the null hypothesis must be rejected. So that's all for today's tutorial. I hope you've learned something. So see you in our next video tutorial. Thank you and God bless everyone.